All right, in this video presentation, what I'm looking at is the solution for question 2 on the Add Math 2023. All right, so it reads, given that f of x is equal to 3x, I'm going to write it, f of x is equal to 3x squared minus 9x plus 1. Express f of x in the form a open bracket x plus b all squared plus c, where a, b, and c are real numbers. All right, so we want to actually do completing the square here. There are many ways to do this. I'm just going to show one method. All right, so if we're looking at a open bracket x plus b squared plus c, what we're going to do basically is just to find a number for b and find a number for c. In this case, most times you would have seen it written as a open bracket x plus h all square plus k. It's the same thing, right? Only that they use a different variable for k and h. So do not feel, weird. It's the same thing. So this b and c are not these, right? You want to make note of that, right? So let us identify from the quadratic what is a, what is b, what is c, and we're going to be finding a number for this spot as well as a number for that spot. So let us write a is 3, b is -9, it's the coefficient of this x, and c is the constant, which is 1. I'm going to be finding this b here, which is linked to what everybody is used to, the h. So I'm going to say that h value is called a b value right now. And you can find this by actually doing b over 2a, right? So you want to take b over 2a, which is -9. So that value is actually going to be -9 over 2 times a, and a is 3. So this is actually -9 over 6. And 3 could have canceled here. We get 2/3. So we have that h, which is now a b value based on the question, is -3 over 2, right? So it's -3 over 2. Now, all I'm going to do is to find that k value now. But that k value is called a c right there. So it is a c. There's a formula that we could use. It is 4ac minus b squared all over 4a. As I say, there are many ways to do this. I'm approaching it from this end. 4ac. 4 times a is 3, times c is 1, minus b squared, b is -9. So -9 squared, all must be over 4 times a, and a is 3. So you want to double check to make sure that everything is fine. So 4ac, right, minus b squared over 4a. So let us find the values for this. 4 is 12 times 1, that's 12, minus 81, because a negative and a negative is positive, but there's another negative there, all over 12. So what we want to do quickly is to subtract 12 minus 81. That's going to give us -69 over 12. All right, so 69 over 12, 69 over 12 is fine. We cannot break it down. It's like -24 over, so it's up to you. This could be canceled down to -23 over 4 if I use 3 to cancel, right? So if I use 3, I'm getting that. So basically, I've just found that k value, which is a c in this case. So what we're going to do now that we have this value here and this one is simply just to put it in the form that they requested. A is going to be on the outside. So 3, open bracket, x, then we put the -3 over 2, square this. At the back, you'll have -23 over 4. And this is the form that they had requested. All right, so after that, the question went further. It said, state the coordinates of the minimum point of f of x. Now, the minimum point of f of x is a combination. So if I've written, if I have this, if I put the quadratic in this format, now this value here, the opposite of this value, right, is the axis of symmetry here. So the axis of symmetry is actually where x. So in this case, if we are looking at this right up here right now on our screen right there, we're saying that x minus 3/2, if you let that equal to 0 and solve, x would give you positive 3/2. This is our axis of symmetry. Now, this value out here is actually our lowest value. So our minimum value is where y is equal to negative 23/4. So the coordinate of the minimum point is a combination of the axis of symmetry and the minimum value of that function. All right, so we set that up. So in other words, then you can easily look at the form that we just wrote the quadratic in and then pick the values. 2 marks for that. Next one, it says the equation 3x squared minus 6x minus 2 equals 0 has roots alpha and beta or beta. Find the value of 1/alpha plus 1/beta. All right, so this one comes with what we call the sums and products of roots, the relationship between the coefficients. Now, what we want to do is to understand what the sum represents. So in other words, the sum, which is alpha plus beta, is actually equal to b over minus b over a, and the product, which is actually alpha times beta, that is equal to minus, or no, not minus, that is equal to c over a. So what we're going to do first is simply, let's write down what is a, what is b, what is c. A is the coefficient of the square, it's positive 3. B is the coefficient of the x, and it's a negative 6. And the c is a constant value right there, it's negative 2. You want to double check, making sure that you made no error. These are the key to unlock what we're about to do. Now, what we want to do is to understand that if you're going to be looking at the sum and product, you're going to have to make every effort to express the idea such that you can see sums and product. So I'm suggesting that you take this, which is 1/alpha plus 1/beta, work it. It's an algebraic fraction, so here we go. So we could do a quick cross multiplication. Beta times 1, alpha times 1, alpha times beta, right? So that is going to give us beta plus alpha all over alpha beta. So that's me working this fraction. Now, if you look on top, you're seeing sum. Underneath, you're seeing product. So we're going to substitute, right? So let us find out what the sum is. The sum, here it is. Remember that the sum is actually, so alpha plus beta, which is the sum, is equal to minus b over a, and that is going to be minus b. B is negative 6, so it's going to be minus 6 over a, and a is 3. So we have positive 6 because these two negative will become positive. 6 over 3 is 2. All right, so the sum is 2. The product is going to equal to c over a, and c is negative 2. A, positive 3. So we have negative 2/3. Now, what we want to do is to substitute. Very simply. So I'm going to put the sum up here, which is 2. So I'm going to have 2 at the top, and the 2 must be divided by -2/3, because it's the sum at the top, and then I see the product at the bottom. So we substitute the values for that. This is simply 2 over 1 divided by -2/3. We're doing ordinary fraction. 2 over 1 multiplied by 3. That's a negative. So 1, 2 into itself 1. So we have a -3 for the answer, right? So the answer is -3. So 1 over alpha plus 1 over beta, when you evaluate that, you will get -3. Let's move on to the C part. All right, it says John's parents started a university fund for him at a bank with $4,000. With $4,000, the bank offers 2 options for interest. Option 1 is you're getting $240 per annum being added, and option 2, 5% of the current balance per annum. Determine the sum of money in the university fund at the end of the at the beginning of the 9th year. What you want to look at is to kind of have an understanding of what you're about. Firstly, let us not jump to conclusion. Let us write down what we have. Currently, we start off with 4,000. Now we're gonna get, so option 1. So I'm looking at option 1 here. So on option 1, I'm gonna get 240 at the end of the year. But if this is year 1, I'm not gonna get this at the beginning of year 1. So I'll get it at the end of year 1, which means when I look in year 2, the beginning of year 2, I will have this. And then the beginning of year 3, I'll have this. So basically, if you continue to look at the progress, right, that you're seeing, we would have an arithmetic progression where the common difference is $240. So in this case, I am seeing A, which is my first term, to be 4,000. The common difference is actually 240. That is being added each year. So that's the difference between this year and next year and last year. There's a difference, common difference of that. The only trick is that you got to understand that the beginning of the 9th year, you have to take it as year 9, because year 1, which is the first year, is the 4,000. The second year, which is at the beginning of the second year, you receive the first thing being added. So the 9th year will work out perfectly. So we are actually trying to find what is that sum up to term 9. The general formula is that A plus n minus 1 times the common difference will give me that term up to that 9th term. This is a general thing. So we're looking at term 9. So basically, we're talking about 4,000 plus 9 minus 1 times 240, because we're going the beginning of term 9. So we have 4,000 plus 8 times 240. So let us check that quickly. 240 times 8, that's going to give me, so I have 4,000 plus 1,920. So I'm looking at 5,920 right there. So my response here is that $5,920 would have been at the beginning, not the end. It's going to be the beginning of year 9. So the beginning of year 9, I have 5,920, which means that this happened the ending of the 8th year, but it still go over into the beginning of year 9. All right, let us look at the other one now. So that's option 1. Option 2 suggests that would have 5% of the current balance per annum. So let's look on option 2. Option 2. Option 2, we're having a 5% on the current. Well, this is like a compound interest, right? So let's talk about what we have. So the first year, you'll have 4,000. That's year 1. At the end of that, which will go over into year 2, you're going to have your 4,000. But it's going to be multiplied by that interest, which is, it's going to be increasing. So it's going to be 1 plus 5 over 100. So that's what's going to happen. But you're going to realize that when you work this out, this piece will simply give us 1.05. And the same thing is going to happen the next year and the next year. The ratio of change is going to be a 5%, right? 5%. So a simple way to go to year 9 is to understand that year 9, the ratio that we're dealing with here, right? The ratio that we're dealing with here is that we're having a 5%, which means that this will actually go up to 9 minus 1. And why so is because AR to the n minus 1 is the formula that leads us to that last term that you intend to find. Right? So that last term that you intend to find. R is the 1.05. This is what is changing the thing year by year by year. So in this case, you start off with 4,000. This is our A value. Our R is that 1.05. And you're going up to term 9. So it's going to be that times 1.05 to the 9 minus 1. 4,000 times 1.05 raised to the 8. All right, so in context of how you operate, how you work this, because this one is a geometric progression because the common ratio is 1.05, right? Every year, 0.05 is being added. Total, you'll get back what you have, and you're getting 5% more. So you're multiplying by 1.05, 1.05. So let's work that out. Let's find out quickly. 4,000 times 1.05 raised to the 8. And this basically would be 1.4774. I'm just writing this out, right? So if you multiply this by the 4,000, you're going to get $5,909.82. So option 1 would have given us 5,920, and option 2 would have given us 5,909.82.